So you will note that on the repository, which is now public, that it comes up with a readme.md file. And in GitHub, when you create a file called readme.md, that tells GitHub that this is a documentation file and that the formatting for readme.md applies, which means that you could do things like bold, bullets, I'll show you some other examples that have more complexity than this. So here you see I've built out a table. I actually have code examples. Now let's walk through this a bit. So in our practice, in my organization, we have the big overview. And then we always specify the requirements section. What packages does this repository require for this build to successfully complete? What versions and who's providing it? I don't exactly follow this in the class that we're having now, but in the real world, this is how we do it. And when I see code in repositories that doesn't follow this format, it's followed by a corrective action conversation to get it right. Each file is explained, and then there are instructions for deploying this package. You'll notice there's a section in this case for development and a section for production. Because sometimes when you do things in development, they're not going to look exactly like production out of necessity. And so in this case, for development, we don't have it, we're not setting up a job sub server, and this NFS blob storage for this client integrates with all of that. Then there's the procedure to test it, and caveat, which is just a fancy engineering term for warnings. And then you'll look here, we have something called a nomenclature. Does anyone not know what nomenclature means? It's a naming standard. And in engineering, we should have nomenclatures. And then you will note that we have things like stop immediately. If you don't know what a Terraform state file is, if you don't know what that is, you have no business being here. And then we describe the directory hierarchy for this particular repository. Or should they, I'm sorry, for our nomenclature. Now, often we don't have multiple code pipelines, but sometimes we build some pretty complicated stuff with multiple stages. And so we have to have the complete repository broken up into directories. Why? Because in the DevOps world, we want our batches to be small. You could do a Terraform in one single file, and I've seen stuff like that. A case in point, and Josh could attest to this firsthand, when you deploy cloud control, that's what OEM is in the Oracle Cloud. Look at that Terraform file. I mean, it's over 14,000 lines. And you have to really know the code to figure it out and reverse engineer it. More importantly, God help them if there's a defect and they have to figure it out. Okay, so then we have a section here that explains the hierarchy and the branching methodology. And I talk about a sandbox, a quality assurance, and production subscriptions. So our sandbox is the David Kent cloud subscriptions for the various cloud providers, AWS, Azure, and OCI that we work on. Right now, we're not doing anything in GSP. And so our sandbox is what we have in our company. And then we really push our clients to require a QA subscription, which is where we'll quality assurance test stuff. Some clients don't have that second subscription. And then there's the production subscription. Now, I even put in here, recall in DevOps, we introduce changes in small batches. There's good reason for it. Then I talk about what the release branches are. And then I have a warning, which is a stronger word than a caveat, and references. Then I describe the nomenclature for naming Terraform files. Why do I build it like this? Why not do it like Amazon or AWS does with one big Terraform file? Well, if I make a mistake here and I get a really weird error, and face it, most of our compile errors are not human readable and take a lot of work to figure out. Well, if it's one really big file and I'm making one change and it's going to affect sequence file number 2, and a colleague of mine is working on sequence file number 8, and we're developing independently, and we do a merge, and the stuff doesn't work after we do a merge, it gets really tough to figure out who did what and how to fix the problem. And I don't mean that in a negative way. I mean in a frustrating way. So by breaking up to very, very small batches of code, that will help you to say, okay, we always define the versions, we always define the backends in 01_main.tf. That is our standard at David Kent Consulting. So if there's something wrong with a version and we're pulling the wrong version, or there's a defect in that version, then we know that the only place we're going to look is 01_main.tf, because that is our nomenclature. Okay? And then we have more information here on, and then, you got to have more warnings. And this is a big one. This is a defect that has been around for over 3 years now. So you got to point the ugly stuff out and hope that if someone is following your footsteps, that they actually engage in good developer practices and read the documentation on the code before they execute anything. And then we have an example of how to apply this, how to build it, an embedded reference link here, the actual instructions. This is the cheat sheet right here. Here's the recipe for building a pipeline, developer pipeline. Here is the recipe for a release pipeline. This is a lot of work. It takes time to document. But invest it now or spend more time doing stuff later. In addition to that, within our code itself, we'll have documentation. So we'll have the name of the file, who the author is, what its purpose is, any comments, an audit log, and any caveats. If you're not documenting your code when you write it, you're not doing your job. To find out how to format the readme.md file, let me just take you back there. This file here, you simply do a web search, GitHub format readme.md. I'll tell you, sometimes I'll do a Google search. I don't like using Google anymore because I value my privacy. But their engine is a bit more refined in technical searches. And sometimes that vendor pay for it prioritization is helpful when you want to see the developer information and not everybody's blog that may not be accurate. So you got this about readmes at GitHub Docs, and this is everything you wanted to know about formatting a README file. And you can see all these links here. You can just keep digging and get more and more. But it's like anything else, we use typically a fraction of all these features. Learn what you need to get the job done and ignore the rest because the reference material was online. Now, a word about branching. If you do a web search on Azure DevOps branching, you have this document that pops up at the top, Git branching guidance. Now, this is using Azure repos. So Azure DevOps has something called Azure repos, which is deprecated. Deprecated means that it's still supported, but other than major fixes, there's no more development on it. The future for Azure DevOps is GitHub. But the strategy is sound. And this is so important when you want to collaborate. It's so important when you do branch merges and you want to implement the quality controls and the approvals. Right here at the top, keep it simple, Sam. Keep your branching strategy simple. Don't overcomplicate this. So here's one strategy, which is you have a feature that you build, and then you have bug fixes to follow. We don't use this strategy. It's too simple for us. We need a little more complexity than that. This is the strategy that we use. We create a release branch, and then we have, not shown here, but what I would do is I will branch I create the release branch, then you have to edit something and push it, and commit it, I should say, and then you have to push it. So after you create the release branch, you have to edit a file. So I'll just hit enter on readme.md or some other kind of frivolous change and commit that. And then I'll do a push to GitHub. If you don't do that and you go switch back to the master branch, then the edits you have just made in the release branch apply to the master branch. It's quirky. It's just the way the tech is designed. It needs to know that this is a real change that's being made. So the way you tell Git that you're really doing that in your Git state file is you commit that change. And the way you get that release branch up to GitHub is you push it. The way you get changes from GitHub is to pull it. And the way you merge branches is you switch to the parent branch and you do a merge from your release branch. Now, what I do is I will create a release branch, do a simple edit, commit it, push it, and then from that, now, once I've done that, the team has access to the release branch. Then the next thing I will do is I will create a branch called Hank Development and switch to it on my development desktop, and that branch stays on my desktop. Nobody sees it but me. When I want to, so that I'll use the same practice as I did with the release branch. I will create it, then I will make a simple change, commit it, but I'm not doing a push because I'm not pushing the development branch Hank_development anywhere. When I'm finished with that, I'm going to delete that branch. I'll discard it once everything's been merged into master. It won't be needed anymore, unless I want to keep it for whatever reason. And then I will do my development work off of Hank_development. And I'll have this container running with Terraform and with the cloud CLI, whether that's Azure, AWS, or OCI running within my container. Why? Why does this matter? Because I don't have to give a damn about what is going on with how corporate is managing my desktop now. I don't care. Now I've taken the operating system out of it and I can be a faster developer. So I do all of my testing of my code in containers. That's my initial test. In a Docker instance container running on the desktop, and I don't necessarily need Docker desktop. I can do this on Windows with Ubuntu 10 and then running Docker CE on there, and I can create persistent storage from that container to the Ubuntu instance, and that Ubuntu instance can have persistent storage to the Windows OS where Visual Studio Code sees the actual code. And when I do a branch switch, then that just goes up the chain or down the chain, the hierarchy, to where I'm actually going to run a Terraform apply from, or a plan or validate. There we go. So, has anyone had issues? I know you had an issue, so you're going to look on with your colleague there. You're resolved. So, and are you good? So, if you could pair up with the gentleman from Sanjak over here and watch along with him as we continue the labs. Anyone else with issues? And we've all, for those of us who've not had issues, we've been able to clone the code and you have it on your local desktop. Very good. All right, we're going to review the Docker file. And actually, before we review the Docker file, I want to take you to the README file in the Git repository. So at the time that this was authored, it was developed on that version of Mac OS, and this is what was installed to get this code to work. And look here, this code has also been tested in Azure DevOps with an AWS connector using Azure pipelines, Terraform Tasks by Charles Zip. So Charles was an early innovator and with Microsoft, and he created his own unofficial marketplace plugin for Terraform for Azure DevOps. A lot of developers use the Charles Zip plugin. For some reason, a lot of corporations dictate that you will use the Microsoft officially sanctioned plugin. This is your choice. Both get the job done. But I personally like the work that Charles Zip did more than the work that Microsoft did. So here are the instructions. You'll have Docker desktop running. You've already pulled the repo. You've changed to the directory where you clone this repo. And when you build a Docker container instance, you're going to run docker build -t and tag. That is just an alias. We'll call that the name, but the real name is a non-human readable value. So we create a tag or an alias, and that becomes the container name. And then dot just says, look for a file called Docker file, which is case sensitive. So if you miss the case sensitivity on Windows, it might run. On anything else, it'll fail. Then change to your home dir. Well, that's one approach. The approach we're going to use here today is you're going to change to your directory where you've put the code repository. Then you're going to start the container instance. Now this squiggly bracket here, you probably have to change that in PowerShell. I've got a cheat sheet for that, and I'll pull that up momentarily, but on Linux and Mac OS, that's the syntax you mean. And what does all this mean? Docker container, so we're doing a container operation, run. We're going to run a container, and typically when you want to spawn a container from a container image, this is how you do it. You've already built that container image with Docker build. And then -- name, that's where you're going to give it an alias. And that's the alias name in this case. -v is for a persistent storage mount, because you want your code to be mounted into the container. You don't want to be using Docker copy, container copy commands. That's just a pain in the neck. There's no reason for that. This way, when you make a change in your IDE, or you do a branch switch, then those changes are visible to the running container instance immediately. Now, a word about branching and testing. What I will often do, remember I talked about earlier, I'm working on a project. I have a scheduled release pipeline that builds in the morning before I turn on the computer. It builds my project in the sandbox. And then in the evening, I have a release pipeline that destroys it. So what I will do is I'll go into my development pipeline first thing if I'm in the middle of something, and I'll switch to my developer branch, and I'll do a Terraform apply. Just Terraform validate, Terraform plan, Terraform apply, just to make sure my stuff changes, or my changes apply, and then I'll do a branch switch back to the release and do a Terraform apply again to make sure that my changes successfully reverse. And I'll do that throughout the development process. I'll make a small change, go to my developer branch, do an apply, make sure that the changes apply. Then I'll switch back to the release and do a apply, which will remove the changes in my developer branch. Why? Because sometimes in the provider modules, and this is notorious in AWS, a defect will leak through. And I want to understand what the conditions are that allowed that defect to leak through. So if I have to open up a ticket with AWS and say, hey, your plugin is broken and I can duplicate it, and this is exactly how I did, and here's my code. When you open up a ticket like that and you have those kinds of disciplines, you will shorten the distance between the dots from the defect to its resolution. And you might even get a resolution the same day. So that's persistent mounts. And then on the left is, again, PWD. You can substitute that with your fully qualified path to where the code is. Colon is just the meta character separator. And then this is where I'm going to mount that storage within the container instance. That's the mount point. And then I provide the name of the container. Now, -dit basically means that that container is going to continue to run. Container instance is a process on the stack, on the process stack. And it launches, it does what it's going to do, and then it dies. Often in containerization, when we build apps, or when we do full stack development, we might have a container instance that runs as part of a job. And within that container is the code that does that job. And then that container goes away when that job completes. Why would we develop like that? Because, well, think about the Banner code tree and all that frickin' COBOL code that's in there. And think about the fact that, okay, I need to push out a change. I need to test it. In the old days, it was, and Lucien, frankly, is still running in the old days with the production product. When I worked for them, they would push out the code as a new distro. I would download it to the client side as a professional services consultant. I would run the code, and it would fail. And then I became the tester. And I would fix the Lucien code and then open up an internal ticket to development and say, well, this is what you did wrong. This is what I did to fix it. Now go fix it and push out a new distro. That's very inefficient. Well, first of all, untested code is bad. But secondly, it's very inefficient. Because not only are we dealing with the code itself, we're dealing with the full operating system. If you build a new container image, you've eliminated the operating system from your analysis of the problem. And now in today's world, I could, if the culture of this organization is right, then I could go to development and say, here's my code change, and here's my Docker file. Go build it, prove it, and push out a new container image. Now, for my professional services consultants in the field and for my customers, instead of having to build that, all that is necessary is launch the container, put in the Oracle connection strings, and go. And pull the credentials from Azure libraries. You know, when you actually launch that container in the release pipeline, it all happens. And for our OCI development, as one person here knows, when we make changes, we simply push another container onto the machine that's running that container. And anything that is local to that client is a persistent mount on that container. And the actual fingerprint keys are pushed when that container gets built. But it all comes down from one source. It comes from GitHub. And that's where the code comes from. Okay, so you see we've got instructions here. First, you run the container. Then you're going to establish a shell with the container. And you're going to do it as this user. And then you're going to take these remaining steps. You're going to set up your API key on a service user in AWS. You're going to run AWS configure and fill in the information. I'm going to show you how that's done. And then you're going to run AWS IAM list users to make sure your credos work. And then you're going to actually eventually build that container. Let's look at the Docker file. You see how it's got a little icon here, Docker file? This is what actually builds the container instance. The first statement we have is a from statement. And you see when I hover over from, the IDE gives me a little bit of help. From Ubuntu, that is the container registry, colon 20.04. Colon is a meta character that tells me that I'm providing a tag, and I'm going to tell Docker that this is the specific version of Ubuntu that I want. What is often done in the by trainers is latest. I hate repository colon latest. I hate that. Pin it. Save yourself headaches. env is how you set environment variables for the running container instance. And these are required for PowerShell, which actually we install PowerShell onto this container instance when it builds. Runs these commands in this order imperatively on the container instance during the image build. So what's actually happening is when you do the run Ubuntu colon 2004, Docker is going to check, do I have this image locally? No. I'm going to pull it. Can I find it? Yes. I'm going to pull that image down. I'm going to launch a container instance immediately, which is a temporary container instance for the sole purpose of building a layered image that will eventually be written out as a local image copy on this Docker desktop development workstation. Again, you can do everything. You can do all this on CE edition too. Now I've got a running container instance, which is a temporary instance, and its sole purpose is to create this image file when I did the Docker build. So it's going to proceed to run these commands. We're going to update, upgrade. We're going to install the following. You see the backslash at the end? That's a meta character that basically says continue this line. So when you use the meta character backslash, you must follow it with the meta character ampersand, which means and do this next. And you see we're doing a wget, we're doing d package, Then we're installing a few more things. And the last thing we do is we install AWS CLI. And you see in each case, I'm including the -y. Now, you might wonder, how did I figure out the packages? It's just brute force. You got to hack at it until you figure out everything you need. Remember, as developers, we're puzzle solvers. We have to be good puzzle solvers. We have to play chess with code. And then I have another run statement. And why did I separate all this from this? Because when I combined this with this, something failed. And I just had to learn that through trial and error. And now you see the next thing I'm doing is I'm installing Terraform. And why am I doing update and upgrade again? Because sometimes when you install a package, that might force an update to something else in the base package. So I have to do it again. And again, trial and error. You don't always have to do it. Now you see all the packages have been installed. Now I'm going to create the user cohesion. And I define the shell. Now I make a directory called home/cohesion 2022. Next, I change its ownership. And finally, I do a change mod. Now, note about that change mod. The inexperienced developer or the developer who is lazy about security is not going to do a change mod on the home dir and other important directories where sensitive stuff is. Well, what's the problem with that? Let's take that WSO attack that I talked about a few days ago. Let's say the container instance gets busted into. If we didn't do that change mod 770, what do you think would have happened? They would have been able to scan down everything in /home in that container instance, and they would have been able to see it all. That would have been pretty ugly. Then they could have done a lot more damage. You got to be secure-minded. You've got to think about keeping the bad guys out when you create the container image. The important thing here is you're not dependent on a sysadmin to do it. You, as the developer, you handle that. Then you see I'm copying a profile file up. I could have just as easily directly created the profile file from here, but again, in keeping batch sizes small, I consider .profile to be to separate that out into its own file. This way, if there's something wrong with the profile, I just go in and edit .profile. And then finally, I have to actually load that profile. And then, assuming that this runs successfully, the container instance stops, and Docker Desktop or Docker CE will then build that image. If it fails, depending on the build options and how it failed, it may leave the temporary container instance there that then you may have to follow up and clean it up. And how do you identify that? You would do a Docker image ls, and if there's a container with a weird name, then just delete that container with the weird name. Be warned though, if you do a Docker build and you don't use the -t option, you achieve the same result, where Docker will name the container for you. And what are the names? The names are names of famous developers or famous hackers. That's basically how that algorithm works. It's kind of weird, I don't know why they chose that, but okay, whatever. kind of humor that I don't appreciate. So we have just walked through the Docker build. And now we're going to move on to the next lab. And in this next lab, first of all, you have already verified, for those of you who are working fine, that something like the hello world container instance actually ran on your Docker desktop. If you have not done that, then this will fail. So you're going to go to the parent directory of your code tree, and you're going to build the container image. If you've correctly cloned the Docker file, the repository, the Docker file is sitting there, and it should just run. Then you're going to launch the container instance. I'm going to pull up for PowerShell users the difference in the syntax. And then the last thing you're going to do is you're going to establish a session on that container instance. Let me pull up that code for you for PowerShell users.